This is Algebra lesson 4.5, scatter plots and lines of fit. Okay, it's going to be kind of a simple lesson today, but I will show you. Sometimes people make scatter plots to show data. Okay, a scatter plot would look like this. Okay, you're going to make yourself your regular table-looking table, and or your regular-looking like line plot, and it would be like this if I said, okay, in the year 2000, and then 2001, 2002, 2003, 2004, 2005, etc. You know, these are the number of cars sold in the, you know, and we'll do it in the by the thousands. Does that make sense? By the thousands. So like this is 1,000, 2,000, 3,000, 4, 5, 6. 1, 2, 3, 4, 5, 6,000. Okay, here's the deal. What you would do is, this is by the different dealerships or whatever, you know, like, okay, here's some data, and the data goes like this, and it goes, okay, in 2000, there's one here, 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 here. Okay, what they do is this. This is just the data from different car dealerships that are you know, telling them how many cars they sold during these years. What they might do is this. The reason why they do this sort of a plot is so that they can predict the future. Okay, that's why they do this, is so that to help them predict the future. And to look back and look at the past too, but to help them predict the future. Couple of things. One, what is the basic trend here of this scatter plot? What is going on here? Over time, what's happening? Over time, what's happening? Yeah, it's going up, right? They're selling more cars, agreed? What you have to do is this. You as a mathematician, you have to do your best to draw a line that is closest to all the data. If you're saying this looks like it's going up, you got to draw a line that looks like it's the angle at which it's going up. So you might go like this. Do you agree that that line is pretty close? Or I could have gone like that. Do you agree that that line is pretty close to the angle at which it's been going up? Right? What I did here was I just drew a line of fit. Okay? This whole thing is called a scatter plot because there's not like, we're not doing this. What we're not doing is we're not going like this and drawing lines from each one. You know what I'm saying? Like, we're not doing that. We are drawing ourselves a line that looks like it's going through the data. Does that make sense? Is this exact? Is this perfect? No. It's just showing that it's an overall upward trend. The reason why they do this is, one, they can see where they've been. And two, you can also look and go, okay, well, let's look at this dealership right here. How's that guy doing in 2002? Oh, he's way below the average, right? And this guy here, he's doing better than the average. And on this year, you see what I'm saying? You can look at this and compare, you know, okay. But the main thing about this is that what if I was to say, okay, in 2006, where do you estimate sales will be? Well, if you in 2006, that would be somewhere, that's going to be somewhere along this line right here. And you can just continue your line and have it look like that and go, oh, okay, it looks like it's going to be about how many cars? 8,000 cars. Does that make sense? You draw a line of fit to show the pattern and to show somebody else the simple, there's the line that we're going to go with. Could your data actually land down here or up here? Absolutely. Could it be there? No, it could be, but where do we expect it to be is right there. Does that make sense? You draw this to help predict. Now, let me draw another one here. Tell me if you see something here. What does this, I need to make this much bigger. Sorry, some of them are big, some of them are not. What would you say is going on with that graph? It's going down. It would be called a negative trend, okay, or a negative correlation. All right? You would call these correlations. This would be a negative correlation. The one from before, if it goes like this, that makes it a positive correlation. And sometimes you'll have data that looks like this. And you go, what's the correlation there? There's nothing. It's just kind of all over the place. You would say there is no correlation. Does that make sense? We did this last year for one lesson, I believe. Positive correlation means it's on its way up from left to right. Negative means it's on its way down from left to right. No correlation means the other thing you have to be able to do is take this, take your data. If you say it's going up, now listen, can you have this right here? I know that that's kind of a mess with my lines there. That looks very positive, agreed? What if I have one guy that's out there? What about him? What would you call him? You'd call him an outlier. He's just a weird one. And you could even have one way down here. Just overall, I mean, look, I could have, I could have this here and have it be like this. This could be stocks or whatever, and you can see that there's obviously, and there could be a few, several people that are out there, but what would you say overall is going on with this trend? It's a negative correlation. Do you see what I'm saying? There could be a few guys out here, but overall, look at the majority there. How would you draw the line of fit? You just got to try and grab the center of this thing, right? Just try and grab the center of it as best you can. Make sense? Okay. And you use that to predict data. You can also use it to look back and go, okay, back in 2003, how many cars did so-and-so sell or whatever. You can use that for that too, but anyway, guess what? I think you're good. Don't thank me now. No. All right. We have page, 248 to 249. I am going to add a few things, though. Not much. Let's do 1 through 2 all, and 4 through 8 all, and we're going to make this not through 49. It's going to be through 51. And (22) through 32 all. 22 through 32 all. It's the spiral review. Okay. Notice they're alls, right? So you're doing not evens, they're alls. Read the directions. Each one I want you to do it exactly what they say.